Hello everyone, and thank you to follow this presentation. I am Anatigo Ferra, and I will present you a part of my postdoc in the Cumming Institute in Columbia University concerning rule and reward-based decision-making in macaques. If I tell you that this item A equals B and B equals C, you can automatically deduce or infer that A equals C by understanding the linearity of this series. Such deduction, called positive inference, refers to implicit serial learning of neural relationship between adjacent items to create a representation of a hierarchy, whether verbal or non-verbal. This ability is ubiquitous in vertebrate and contributes to a wide range of phenomena, from numerical reasoning to economic decision-making to inference about social hierarchies. However, the cognitive mechanism of positive inference remains unclear, particularly with regard of contribution of reward associated to item and rule-based inference. To understand this contribution in learning, we create a concept between rule and reward-based learning during a serial ordering task. A monkey was trained to learn two differentially rewarded lists, small reward list and large reward list, each containing 5 stimuli. The monkey was trained exclusively with adjacent pair within each list. And the monkey don't have any expectation of disorders. Following training of adjacent pair, monkey were trained of novel adjacent and non-adjacent pair with a distance of 1, 2, 3, or 4 between pairs from within lists and between lists. Selection of a higher ranked item resulting in reward. We perform an experiment with the presence of reward disparity between lists called unequal condition that we compare to equal condition without reward disparity. In such layout, we were able to descend the reward seeking referring to the reward-based decision and the understanding of distance suggesting a rule-based decision. And so we have 3 main groups of pairs. So within list pairs with reward association concordant with rules, exactly like in the training set, and the between list pair with 2 possibilities. First, the reward is concordant with rules and no conflict is present. Second, the reward is not concordant with rules and we observe a conflict. So let's decompose the behavior into different parameters using logistic regression analysis. We admit that the performance for each monkey is a function of an index of performance modulated by the reward level and the symbolic distance between items. If we observe the performance at the beginning of the training during equal and unequal condition, we observe the performance close to chance level, showing that the subject did not have any expectation of the order of the list. Then a positive index for within and between list tests reveal a similar overall performance above chance, despite of the presence of reward disparity. Concerning the impact of reward on the performance, we did not observe influence of reward during training. However, we observe a small influence during within list pair presentation and a large influence during between list. This reveals a bias on performance due to reward disparity even in within list condition. Finally, concerning the influence of symbolic distance, for pairs shown within and between lists, we observe a larger effect of symbolic distance of the performance, similar between equal and unequal reward condition. This result suggests the creation of the mental representation and the following of the rule at the same level, despite the presence of reward disparity. So, knowing the effect of reward and rules on learning, we can observe the reaction time of the specific pairs like BT. The interest of these pairs is each item are neither adjacent item nor terminal item. And so both stimuli have equal reward rate and called critical pair. So for the pair BD, we can see a reduction of performance when B is from the small reward list and D from the large reward list. The orange dot. Interestingly, we can observe a slower reaction time for B small, D large than D large, B large, D small. This difference is not present during equal reward condition. This result suggests a longer time to take decision between stimuli, and so a competition between rules and reward-based decision making when the higher item is from the small list. So to conclude, monkey can make rule-based decisions despite of the strong reward disparity. And the performance reflects a reward-based decision often associated with model-free reinforcement learning algorithm, and rule-based decision, often associated with model-based reinforcement learning algorithm. So we observe the influence of two cognitive process, decision-making and learning, despite of reward disparity. The next part of this study is to understand how both processes are integrated over time during the learning, using electroencephalography. Thank you, and I would like to thank Vincent Ferreira, Craig Jensen, Herbert Reyes, and Fabian Munoz. If you are interested, the preprint is available in bioRxiv. Thank you.